Good afternoon, everyone. We again welcome you back from the lunch break. And before we begin our session and continue on commercial initiatives, we would like to celebrate the collaboration between ESRIC and Bocconi University. For that, I kindly welcome on stage Dr. Catherine Hadler from ESRIC and Mr. Mattia Pianorsi from Bocconi University. Please put your hands together for them.
Thanks. Thanks, good afternoon. It's me again. So this is about celebrating great enthusiasm and shared commitment to advancing our own mutual objectives. And that is, we are announcing the signing of a memorandum of understanding between ESRIC and between the C-Lab of SDA Bocconi School of Management. As you all know, ESRIC focuses on the science, technology and business of space resources. We do research, we have our community activities, we support business through the Startup Support Programme and through the Accelerator. The C-Lab of Bocconi, of School of Management, is renowned for its expertise in the space economy. And so in this respect, it can provide insights into business, financial and geopolitical aspects. So we see a huge benefit in signing this Memorandum of Understanding. The intention is to support collaborative research projects, to develop a working relationship, and really both sides bring complementary skills. ESRIC, with its expertise in science and technology related to space resources, and the C-Lab, with its expertise in financial aspects. And so it's with that we are thrilled to be looking for opportunities to work together and to collaborate and develop our research programs. Mattia.
Thank you. Thank you very much. And on behalf of my director, Professor Simonetta Di Pippo, the C-Lab team and the Bocconi School of Management, we are very happy about this partnership with ESRIC. Indeed, we believe that the combination of skills and expertise in light of multidisciplinarity is key for the advancement of the space sector, specifically in times like those ones we are living right now, with a changing environment, with public policies that ask not only for technical feasibility, but even for economic sustainability of space ventures. So in light of this, our partnership, I think, is key for advancing in space resources research and maybe something more in the future. Thank you very much. Thank you. Thank you very much. So right now, the new partner gave me the opportunity to give a speech. I don't want to be so long. Maybe if you can upload the slide. Basically, I would like to make some thoughts about the future of the space sector and the space economy. This is something that we are working with other partners of the C-Lab, specifically the Space Policy Institute at George Washington University and the Secure World Foundation. And recently we said, all right, so after the great financial crisis, we all know that the interest rates were very low in the market. So basically investors probably were looking for higher yields in the market. And the space sector maybe could fit this kind of purpose. If you can upload the next slide, please. I can hear, okay. And basically, they were optimistic about the space assets and the value generated by space companies. Unfortunately, after the great financial crisis, we experienced another big event, the pandemic, and this led to a scenario of high interest rates and high inflation. So what we are living right now, unless central banks in a couple of months, maybe they will cut interest rates, we hope so. But at the meantime, this implied that some assets were subject to price correction. So we had private investors making investments in the space companies. We had some companies that were listed in markets. So a lot of investments. But actually, this kind of scenario could have hit the space companies maybe harder than other sectors or companies in the market. And maybe this implied a kind of price correction. So the assets of the space companies were not anymore valued like before. Maybe with these interest rates and inflation, if you don't have the revenues linked to, in the end, the inflation, your denominator, so in the discount effect, if some of you is, a little bit know about finance, can lead a decrease in valuation of companies. So the question was, but this price correction, as you can see by the graph, in green you see the price index of Nasdaq 100. So basically the index that collects all the first 500 companies in the United States working in technology. And the blue one is an index that collects the space companies listed in the market, so public companies. In this index, there are even not only, let me say, aerospace companies, but even those companies that have core business in the space sector. So like Rocket Lab, Redwire, Intuitive Machines, and so on. You see that after the beginning of 2023, there was a divergence in prices. So on the one hand, you see Nasdaq increasing in value, like we all experiences right now. Maybe there is even a bubble. But on the other hand, you see a decrease in value of space companies listed. So you have a decrease in market valuation. Investors are selling their participations in space companies. So this could be maybe a correction price in assets. We would like to investigate this in our next workshop during the ISC in Milan in 2024. But therefore, it raises another question. Are we sure that there is a perfect alignment between the prices that investors are paying and the value that these companies are generated? And has value, I intend the value generated for customers and the capability of these companies to take a profit of it. We saw before some companies that had, for instance, even a business on Earth, so selling components or materials even on Earth markets. They had a business model not at the front of the B to C or the B to G. They are companies working to be a partner of bigger companies, so providing components or materials. And this is a kind of business model that can be rewarded for these companies in terms of value generation and even in terms of taking profit. Because in the end, it's only when a space company is taking profit for what it's doing, it implies that it's economically sustainable, and it implies that it can give to investors the returns they expected from their investments. Right now, according to the data, we are not seeing that. And if you see the private capital markets, so private equity, venture capital investing in these companies, it is pretty liquid. There are not a lot of transactions. There are not a lot of exits. So this signal, the other signal in the financial markets, and another one that is pretty important, if you consider the employment rate of space companies, I did this exercise in the United States, and you consider the budget of NASA, you see that the pace at which the budget of NASA is growing is much higher than the employment rate of space companies in the United States. So it implies that in a certain sense, this budget is not well used or well capitalized by space companies. So 3 signs so far. I don't want to be pessimistic about the space sector. I just want to say maybe we have to concentrate much more on value generation, and so how these companies actually generate value, rather than thinking, okay, let's grow investments in this sector, let's put a lot of money here and there, if we have actually this kind of situation. So I hope that in the future, the attention of space agencies and governments, and especially people working in the space sector, would be more on this side than about, okay, I raise money, and after maybe you have a kind of bubble. So thank you very much. I hope it was quite clear. Otherwise, I am available for questions. Thank you.
Maybe we have questions, just a few minutes, if you can be on stage, Mattia. Yeah, no problem. Do we have any questions in the room? Yeah, please. Please go ahead. Just a minute, mic is coming. You can come on stage, please.
Michael, thank you for the talk. My name is Dorian from SpaceRadar. You might have said it, I might have missed it, but could you comment on how many companies are being tracked in the space price index? And is there like a high sensitivity to, for example, Virgin Galactic, I think, had a 10x price decrease. So maybe if you remove a couple of these like very volatile companies, what would it look like?
Yeah, thank you for the question. The index is basically composed by, what you first look are the components of the index, and this index is composed by aerospace and space companies. So aerospace like Lockheed Martin, Boeing, and et cetera, So it's not an index that purely track the performance of pure space companies like SpaceX, Intuitive Machines, and et cetera. What I've seen tracking these companies is that when there is a great event, the price increases a lot, like in many other sectors. For instance, Intuitive Machines had a great increase in value thanks to their mission, and right now we see Redwire having an increase in value, and so on. So we can see kind of big increases, and after a bubble that is gonna explode after this kind of event. So, in my opinion, this is only a kind of benchmark. It's not reliable 100%. But if you go within this index, you see like Rocket Lab continuing to lose value and other companies. So you cannot compare upstream and downstream, in my opinion, capital intensive and less capital intensive. The core business is very different. In the one hand, you have the B2B, and the other hand, you have the B2C, almost, in the downstream, if you want. Right now, with Starlink, maybe we will use the internet even with our mobiles, possibly. So it should be constructed quite better, distinguishing not only in the value chain, but even in the core business of the companies. But still, this one, like the other work Kensho of Standard & Poor's 500, are showing quite not promising performance compared to other indexes. I know that Nasdaq is quite dragged by the Seven Sisters, or maybe Amazon, Facebook, and Apple, Nvidia right now, all right. But in the end, if you look at kind of benchmark, this is what we can find right now. Otherwise, you go in the venture capital market, you see the returns that they have, like 40, 50, 60%. You can take this as a benchmark, but in the end, you cannot track the performance day by day, like you can do in the financial markets.
Are there any more questions? Yes, there's one more, please.
Yeah, I think that the European Space Agency has worked with Euronext to create an index even in Europe, but even this index is quite contaminated. Of course, it's a composed index with Thales, if I'm not wrong, Leonardo, and other companies, so aerospace companies, with helicopter, defense, naval divisions, so not quite reliable in my opinion. We are trying to get investors within the sector, but still sometimes there is not, in our opinion, in our investigation that we would like to do with the next workshop, there is not it's not well understood how this company is gonna produce profits and give back to investors the returns they are expecting. Consider that in the market, there are a lot of instruments and companies giving not the same returns, but you can see right now NVIDIA what it's doing. So why investing in space for private investors? Thank you.
Sorry, just I want to comment something. As you said, you don't want to be pessimistic, exactly. So there is anyway some customers that are the agency. There are motivated investors that believe in space as long-term investments. And there is something that we should not forget, that are the terrestrial application, right? So a lot of technology and innovation that we are developing for space can be reused in terrestrial application. And so this should have a good market, right?
Yeah, this is going to help for sure. In my opinion, it is key for space companies to create technology useful here on Earth in the first instance, so that revenue generation is immediately after the go-to-market strategy. This is for sure. But I see the space economy, the space sector in general, like economics of complementarities. I mean, everyone has a role. The entrepreneur has key resources to invest. He has scarcity of resources, so he had to invest in specific key resources useful for its company. But he or she has to rely on complementary assets to do the job. So you have to rely on other companies, on outsourcing activities on other companies to be able to create an economic of complementarities. What probably we are going to see for the LEO orbit economy in space manufacturing, assembly, private space stations, and maybe in the longer term for the lunar economy. I mean, in the end, a government cannot go to the moon alone. Imagine a company. So we have to do this kind of activity. And in this case, talking about infrastructure, what is very important is de-risking revenues and costs. So, for instance, producing contracts. You do O&M operations and maintenance, APC contracts, supply contracts, so that you can start de-risking your company. Anchor investors, anchor customers, and so on. Thank you.
Thank you.
Thank you. Thank you so much, Mattia. Thank you so much. Please put your hands once again together for him. Our next speaker is Johannes Becker from Lunex, and he would be talking to us about commercially available lunar regolith simulants for European research and its characteristics. Welcome, Johannes.
Good morning, thank you. Especially thank you for the introduction, so I don't have to explain that anymore. I'm keen to make you in the next 10-12 minutes familiar with the simulant system we created. The motivation was that we have seen a significant need within Europe for good simulants. The market in the US is already well established. I think the most are familiar with Exolete, selling about a ton per month. Europe is so far much smaller than that, but we've seen in the past a lot of approaches for good simulants from various sides, especially from university and other research institutes. But these approaches came normally with some disadvantages. So these developments were often made for very specific applications. So simulants for rovers, simulants for specific chemical reactions. Due to that, it was often only manufactured in the quantities as it was needed. So for example, if there was a lunar yard created, then that amount of material was sourced, but not much more. So if a research institute at another place was interested to use, for example, the same material, it was often tricky to get, especially as the billing process between universities is often rather tricky. Due to the often batch process, we got results like inconsistencies in qualities, also the limited availability I already mentioned, and also the high costs per kilogram of simulant available. And also, due to the specific application for the lunar simulants, we've often seen incomplete characterization. So, for example, a simulant for a rover testbed was often well characterized just for that application, but for example, other chemical properties were not that well known. And now the idea of Lunex as a spin-off from the TU Berlin is to use all the heritage and knowledge we already gained in Europe to create a commercially available simulant and to offer that to the whole science and industry community. we started and thought about how could we actually set up a system that could work to offer decent prices and to react also to the very changing demands. So we have some research projects which are interested in sourcing for about 2 kilograms. We have other institutes which are asking for 15 tons. So the range is very widespread. That is why we got to the point that we set up a whole system. I will explain later on. But we have 2 base simulants. We have one for the Terra region on the moon, which we call LXT100. I will explain the 100 later. The T is obviously for the Terra, which is mainly an N-order site to address all those places. Then we have a Mara base simulant, which is mainly a basalt, which is called LXM100. And the criteria to source these products was mainly the chemistry and mineralogy, to get that as close as possible to what we know from the Apollo mission samples, which are well characterized. We are very happy to get a very good fit to that. Then we wanted to have a low alterated bedrock. That is very important, but that worked out well as well. We have a very low water content, and we also needed a long-term availability. So we wanted to make sure that the material you get this year is as close as possible to what we can offer you in 5 years' time, for example, and not to change data sheets with every batch we can offer, but to get a constant supply. This is the chemical composition of the LXM100. I'm not going through all the data here, but you can see in comparison to the Apollo 12, 15, 17 data, which are also depicted there, that we got very close to it and that we are often within the limits or the deviation we can see on the moon from the original basalts. Then you can see here the mineral phases, which also work very well. Then we have also the physical properties depicted here, and also the particle size distribution shown here. I'm not going through all this. If you are interested, please get in contact. I have also some data sheets I can hand out in case that is interesting for you. Instead of that, let's keep on with the LXT, the Terra material, which is also a very good material we found. This is also very similar and comparable to what is currently in consideration by the NASA for the lunar dusty chamber, and also very comparable to what Exolith is, for example, offering with only small changes to it. But yeah, if you're interested in that, please feel free to contact me. Also the mineral phases and the physical properties depicted here, including the grain size distribution, all are very well matched to actually what we have with the Apollo samples. But then let's talk a bit more about the modular system I already introduced a bit. The point is that the lunar regolith is always a mixture of varying proportions of the Terra and Mara material. We also have thermal affected material within it, so glass and agglutinate particles, and also sometimes probes, samples from the Apollo time have shown that they are rich of certain materials, e.g. ilmenite, olivine. So if you want to work with that, especially if you want to get close to the results a beneficiation process might offer you, that is something also that is needed to be addressed well. Then we have, yeah, already said that a bit, depending on the application. So if you're looking for specific chemical processes, it's also interesting to work with the specific materials. And that is why we got to a modular system, so that we can actually offer you the base material, the raw material, and also the specific components that you can start to work with that. That offers us the possibility to reduce the costs for specific samples, and also for you the chance to isolate reaction paths, as you don't have to work with a wild mixture of a lot of minerals and chemicals, but you can isolate the actual reactions taking place. Here's the whole system we have. You can see the LXM and LXT100 on the left. which are the base materials. We can mix these depending on the position you want to get to on the moon, to get to a local mixture. In this case, LXT70, so 70% is Terra material, 30% is Mara. From that on, we can offer you sintering or agglutinates, and by melting, we can get to glass samples we can add to it. And by that, we get to, so we call it advanced simulant. And if we add supplements like olivine, ilmenite, iron, depending on what your needs are, we can get to chemical adapted simulants to address even the most complex situations. By this, I would like to get to a small conclusion. We have right now the LXM and LXT material already available, especially the Mara material. We've ready. The Terra material, we are currently in replenishment. We hope to get that done in June, including a small recharacterization that we are actually sure that even the new batch is fully characterized and what we wanted to have. And then keeping on with the option for adding glass and agglutinates, we can already get that done, even so the Terra material is a bit tricky as it tends to recrystallize. And then the additives, to get to those, we have the very good ilmenite. We are very happy about that. So in case if that is interesting for your processes, feel free to get in touch with us. And we have also a good olivine in case that is interesting. And with it, I would like to get to the end to point out that this is now available either on a commercial basis, or you can get in touch with us, and we are keen to get in research projects with you as a partner. Okay.
Thank you very much, Johannes. Do we have questions? Yes, please.
Jakub Ciążela, Polish Academy of Sciences. So I have two questions. One very short. What are imprecisions to numbers that are shown in the tables, the mineral compositions?
You mean how precise they are?
Yes, yes.
I can look up the deviations between the different measurements we did, but normally the point is that as we work with minerals and vastly changing mixtures, so we normally run a batch of, for example, per sample micro CT, easily 10 measurements, and they are always a bit changing, but I have to look up how much it is, but it's far smaller than the Apollo samples by itself are changing.
Okay.
Much, much smaller.
Okay. Okay, well, so I can check on the Apollo samples and deduce. Good. The second question is about the glass production process. What method have you chosen to produce glass for this regolith?
Sorry, say it again?
What method have you chosen to produce the glass? Because I guess you produce the glass, or you take it from a natural sample.
No, right now we are producing it on our own.
Mm-hmm.
It's a very basic oven process of melting it, and
1,500?
It is depending on the material.
Yeah.
So it's depending on the material, about 1,450 to nearly 1,600. It's depending on.
Okay. Thank you very much. Thank you.
You're welcome.
Yeah. Actually, I have a question,
Sure.
if I can. So a very quick one. Have you thought of the nanophase ion solution? Because that's something which literally separates the simulant from the real lunar regolith.
Yeah, we started to think about that, but that is a very complex topic, and I think we will need still some time to change that.
Cool. Thank you so much. Are there any more questions? A quick one? No. Okay, thank you. Thank you so much. Once again, please thank Johannes. Our next presenter is Dorian Ledger. He's from SpaceRadar CX Bio, and he will be talking to us about SpaceRadar, keeping track of missions in our solar system. Please welcome.
Does that work? Yep. Hi, everybody. Ladies and gentlemen, good afternoon. Really excited to be telling you a little bit about SpaceRadar today. So SpaceRadar is a new company based in Luxembourg, founded in 2023. And before I jump into it, I want to tell you a little bit about the backstory behind this as well. So I can't see the screen, but there we go. Okay, perfect. Thank you. So on the left side there, you see this small creature is myself, 1992. I asked my family, this is preparing for a trip from Grenoble to Montreal. And I spent a lot of time with planes as a kid. You can see, as you may remember, 1992 was a year where purple shoes were very much trending. I never got the pilot's license, but I was always very interested in aircrafts, and I was kind of, on the other side of the equation, very interested in air traffic management, airspace management, and also with computer games, this immersive feeling of being in space with the ships that you're flying with there. So that's a little bit of the backstory. As you know, airspace got very busy in the last few decades. You may be familiar with this platform called Flight Radar 24. It became very popular in 2010 after the volcanic eruption in Iceland. This website has something like 4 million active users per day. It's tracking hundreds of thousands of flights per day. And what about space? Space is going to get busy soon, so maybe we need a space radar. So SpaceRadar is providing a number of solutions for new space, and we aim to connect humanity with the opportunities in our solar system. And today I'm going to tell you about 4 things that we're working on that I'm most excited about, and then give you a little bit about the future perspective as well. So first, we're building this very incrementally. We started off with the Earth-Moon ecosystem. This is clearly where most of the traffic is happening right now. So if you go to our website, you'll be able to see what we call a flight table. You'll see all the upcoming ships, when they're leaving, who's flying, and importantly, what are they carrying. So you can click and see the whole manifest of that ship. And we've built a database of all the available landers and rovers. We're also thinking about doing orbiters next. And to start this path of lunar and Earth ecosystem mapping visually, we've also associated the flights with their orbital trajectories. So there you see a geostationary transfer orbit associated with Luna, the Russian probe. So I want to say this is us finding out where the explorers are landing. This also gets us to think, well, maybe we can help in the decision making of where explorers should go based on economic models of the resources available. So that's exactly what we've been developing. We've been developing techno-economic models for ISRU. And we started off with a focus on energy demand for liquid oxygen production using hydrogen reduction of ilmenite. The first model is built with ESA, specifically Spaceship EAC in Cologne. And we're now in the final phases of a publication in the National Academy of Sciences. Those are all the co-authors there. And what I'm really excited about also is that the National Academy of Sciences is a general readership audience. So hopefully we're going to go a little bit outside of just the space industry with this publication. So I'll quickly walk you through with what we see in the model here. We're starting off with dry regolith on the left side, and then we do a sort of mass flow analysis looking at the 7 steps going from excavation, transport, beneficiation, a high temperature reaction, electrolysis of water, liquefaction, and then zero boil-off storage. We look at the energy required for each of those steps, and from this we can calculate the energy required per kilogram oxygen produced. We repeat this calculation for various ilmenite concentrations, and of course we get this expected distribution. As the ilmenite concentration increases, the total energy required for the production chain decreases. We then focus on 10% ilmenite as sort of a representative value where we think this technology would be used, and we analyze the energy across the production chain. So you can see there the big blue bar, a lot of the energy is used in hydrogen reduction. We also, in the paper, we zoom in to the reactor more carefully and show that it's quite interesting. A lot of the energy is actually used to heat up the hydrogen to do the reaction, not just to heat up the regolith. From this, we're then able to basically take a TiO2 map, convert that to ilmenite, and then add a layer, which is our model, on top to find out how is the energy distribution for mining oxygen in different locations on the moon. So blue areas are more favorable. It's cheaper to get oxygen there. It's about 22 kilowatt hours per kilogram oxygen. Red areas are less favorable, and gray are not mapped because the ilmenite concentration is too low. So we would have to use probably molten salt electrolysis or something else. So this is a publication. We're also now developing web-based applications of this tool so that it can reach a broader audience. So what we're developing here is a beta of a web-based graphical user interface, which we'll offer as an open access tool, but also as software as a service. And so basically there will be a parameterized model here where users can change different parameters of their production chain and then see how the energy look like. We're starting off with energy. We then want to go to more hardcore economics, thinking about the CapEx and OpEx of the production systems. Again, we're starting with oxygen. We may then go to other technologies. So now we know a little bit about how we are going to be able to feed our hungry rockets with propellant and where. But what about the astronauts? So the other technology that we're working on is a food payload concept development, which we called Food Beyond Gravity. And this is a closed loop system that uses 2 stages of microbes. For those of you familiar with Melissa, you'll see some similarities, but also some very interesting differences, which we can discuss maybe after the talk. But what you see here is that basically the lunar habitat will generate some organic waste. Those will be then transferred to an anaerobic digester with archaea. It'll produce biomethane. Biomethane will be sent to a second stage with methanotrophic microbes, and then we get protein-rich biomass that can be fed to the astronauts. So I'm not going to go into all the details here, but if you want to look at the mass balancer, it's indicative of sort of the mass balances in the system. But I want to highlight one thing that I think is interesting, is that we're actually combining here some high TRL technologies and now adapting them for the lunar surface. And I want to point out that really excited that one of our main collaborators on this project is VNG AG, which is a large, one of the largest natural gas distributors in Europe, one of the largest biomethane producers in Germany. They're investing about $5 billion into green tech in terms of hydrogen, biomethane, and green ammonia in Europe in the next decade. And they obviously see a role for methane in the space industry, thinking about HLS and thinking about the future. So we're very excited about being able to bring a non-space actor into this project. And generally, that's something that we're trying to do more of at SpaceRadar. We want to inform more non-space actors, connect with more non-space actors, and get them more engaged. And that's a driver for the other pillar I want to mention, the fourth thing, which is our newsroom and public engagement. So just quickly, we published a first article here called about international space law. We co-published that with Space Ambition, which is aiming to be a VC fund in the space sector. And for our first article, I think this was quite successful. It had about 7,000 reads. Up next, we'll be doing a review of all the different ISRU liquid oxygen technologies from MRE, MSE, carbothermal, hydrogen, et cetera, and national space laws. And we're very interested in hearing what the community would like us to write about. So please let us know, and we'll try to take that on board. And I also want to touch on the innovator challenges. So we did a beta run of this back in 2022 on sustainability. And now we're looking at another very important topic, in my opinion, which is the promotion of peace in space and the peaceful use of space. So we're going to ask, how can citizens promote peace in space? And we'll be awarding prizes to what we consider to be actionable solutions from that competition. So a little bit about our future plans. We're going to be working on some revenue generation strategies, some consulting, especially with focus on ISRU for oxygen, payload brokerage in terms of, we're talking to a lot of universities, and we'd like to be matchmakers between instrument providers and mission operators. And we're exploring the idea of space resource tokenization as well, for example, ownership via NFTs. And we have many more space bio payloads that we're incubating. We're doing crowdfunding, so Since January, we've been active on Gitcoin, which I suppose many of you are probably not familiar with, but I like to call it the Kickstarter of blockchain. So it's a great vehicle for crowdfunding open access research. And then we'll also be kicking off our Kickstarter in May 2024. And well, there's a number of different prizes, but I just want to highlight one here, which is that donors on our Kickstarter will be able to get governance tokens to vote on the editorial pipeline. So with this, I'd like to show you a little bit about our team. We have a very diverse team from a little bit all over the world, hopefully one day off-world as well. About 6 core team and 6 advisors, diverse skill set from software, engineering, chemical engineering, bio, and so forth. And we're super welcoming to new collaborations, so please follow us on LinkedIn and join our Discord channel where we're discussing a lot of technology challenges and funding opportunities and so forth. So there's a nice community there that's starting to build. So with this, thank you very much, and happy to take any questions.
It was a really nice presentation, and it'll be really interesting to know the results of your innovation challenge.
Happy to share.
I think we all will be looking forward to listening to it next year, because maintaining peace in outer space, actionable solutions, wow, we would like to hear that. Do we have any questions? No? Okay. I think it was, okay, sure, please go ahead.
On my side, Dorian, thank you for the presentation and presenting that alternative that we need non-space players within space industry. And I just want to go to the fact that, thank you, the fact that you're thinking also about the crypto or alternative investment possibilities and making the link with the prior talk about stock markets. Do you believe from the inner side that I believe you have of industry so far, there will be a place for not listed companies to make the difference and build trust? Because in general market, we speak of mid-cap companies, SMEs, these companies make money and high margin and bringing money back to their investors. And do you think the investigation towards crypto and alternative industry, funding industry, will be a mean to bring substance and profit into space?
Yeah, that's a good question. So obviously the crypto industry is full of contentious, ups and downs, and I think that will continue in the future. So I don't want to advocate too much for saying that it's like a panacea to funding issues in the space industry. But I think for startups especially, there's a lot of opportunities there. There's a lot of people that are eager to fund things that they find interesting. So there's a pretty deep ecosystem in DeSci and DeFi, and I would definitely advocate for startups to explore it. Whether it can fund, the kind of like a $100 million mission to the moon is something I'm not sure yet. We shall see. The future will tell. For us, it's been a very successful means of funding the open access tools that we're building. Hope that answers the question. Yeah. Thank you very much.
Thank you so much, Dorian. Our next speaker now, moving on, we have Arthur Woods from Astrostrom, and he will be talking to us about Greater Earth Energy Organization. Please.
Welcome. Hello, everybody. Thank you very much for being here and the opportunity to present this idea. Now, where we have it next?
You can see it in the front.
Okay. What I want to talk about today is actually we're launching a public-private partnership called the Greater Earth Energy Organization. Now, the purpose of this organization is to enable space-based solar power. Now, we find that the climate and energy crisis on Earth has created a window of opportunity for space-based solar power that didn't exist actually a few years ago. So there's a lot of effort going on in the world today to develop this technology. So what this comes out of a study we just completed for the European Space Agency called the Greater Earth Lunar Power Station. Now, the focus of this study was, is it possible to create a lunar power satellite that could provide power to lunar operations from lunar materials. So we looked deeply into this study, and actually we found several, there were no showstoppers, but we found several key technologies that have been presented at this conference. You might have seen the presentation by Katrin Christman from Tallinn Technology University about monograin layer photovoltaics. We found this as a key technology that could be produced from lunar pyrite, so we have photovoltaics. The other one you've seen on display upstairs is basalt. Basalt fiber we would use for structural materials and other purposes on the moon. So these are two key technologies that are actually on display here. Now, what we actually learned is that if we could manufacture solar power satellite components on the moon, it would reduce the amount of mass for a solar power satellite launched from Earth by 80% or more. So why is that important? Well, this is an overview of three solar power system concepts, one from China, John Mankin's Space Alpha Mark III and Cassiopeia. And as you see, to launch one of these satellites will require hundreds up to 400 launches from a SpaceX Starship or a Long March 9. So yeah, is that capacity going to be available when we really want to implement space solar power? So what we did, we also looked at the economic concept, and we have identified that the energy market on Earth, the multi-trillion energy market on Earth, as well as the trillion per year energy transition, creates a market opportunity for this to go to the moon. And so we have these flywheel effects. So almost everything that's being discussed here would be included in this kind of concept once the operation on the moon is happening. So this is the economic driver to do this concept. Now, this is an overview of how it would look. This is a two-planet economy. We have lunar production on the moon. We have solar power energy going to Earth, and in the middle we have a cislunar transportation system, which is actually another business case because it would be like the Suez Canal or the Panama Canal in space. So this is the budget that we've looked at. This is a development program. We have 16 billion earmarked for space solar power development. Now, this number comes from the Fraser-Nash cost-benefit analysis that they did for ESA for the first solar power satellite. We have 10 billion for another reusable launch system, and this is sort of a guesstimate of what Musk has spent on Starship. And we have 11 billion for lunar Earth operations, where we would do technology demonstrations and a cargo relay station. But when we get to the moon, we have 44 billion there for the mining, beneficiation, and the production facilities on the moon. And we have 11 billion earmarked for a lunar space elevator, because we need a way to transport the components from the surface of the moon to the assembly location at the Earth-Moon Lagrange point. And we have 8 billion earmarked for human presence. We need some humans on the surface of the moon and at the assembly location in the Earth-Moon Lagrange point. So this public-private partnership we find is the most feasible way to go forward. Now, the aspects on the public side, we have the Greater Earth Energy Organization, and this would be an autonomous multinational treaty organization consisting of nation stakeholders, independent of any other organization or organization. And these nation stakeholders would have a keen interest to have energy security while meeting their climate goals. Now, the private part would be a company like Astrostrom and its strategic partners that would bring together the competence and the technology ideas in order to convince the countries to join into the Greater Earth Energy Organization. Now, these strategic partners would, like I said, supply the competence and the technologies to convince these nations. Now, we will also need some investors in order to set up the operation. So we already have the first list of strategic partners. We signed memorandums of understanding with several companies already, including a space solar power company in China, the exploration company here, a space resources company in Switzerland, and just recently, the Tallinn University of Technology. So this concept would de-risk the financial and regulatory challenges that are inherent in this concept. So this gives us a cooperation dividend, whereas it would also, and this is as important, it would de-risk the geopolitical challenges, because no one nation could do this on its own, and if it would do it, it would probably run into conflict, and especially over the control and the distribution of energy. So if we greatly increase the supply of energy worldwide, we would have a peace dividend. So there's precedence for this. Intelsat, Inmarsat, the European Space Agency, has given us inspiration. ITER, which is developing fusion technology. Now, all nations are welcome to join the GEO. The initial target members will be the nations that already have space programs, because they would benefit from this mostly. And we have kind of a roadmap. Like in the next 2 years, we would need an investment of like about 10 million to set up the organization. And once we have the First Nations involved, we would have a budget of around 100 million a year for research and development. And then we get to the implementation phase, and that would be 10 billion a year. So we have 2 ways to go about this. That makes it a very equitable situation. We have the energy coefficient, which is, we take a population of a country and it's divided by its per capita energy use. This gives us a coefficient, so it's a totally equitable system for all nations. So we also have the fair return principle, which is sort of used at ESA, so that a large percentage of the money that's gone into the yearly contribution would go back to the industries in that particular country. So just to give you an example how this works, this is the ESA budget right now. Switzerland, where I come from, contributes 188 million a year to the ESA budget, where Luxembourg, for example, is 41 billion. Now, here's our 10 billion budget. I know you can't read all of this, but here, using this energy coefficient, Switzerland would contribution would be 127 million and Luxembourg 16 million. Now, if we add other countries to this, and this is a list of 42 countries, including big ones like China and India, also some of the Middle East countries in there, you see that the contribution per country goes down the more nations that you have involved in it. And I mentioned China and India. China and India have very similar populations. However, China has a higher per capita energy use. Therefore, they would pay substantially more into the organization than would India. So as a budget comparison, we have ESA with 7.9 billion a year, NASA at 27 billion a year. So our budget is in between these two, but it's totally focused on space-based solar power. So humanity is at a crossroads. We must soon decide if we want to prefer to live in an energy-rich world, or do we have to adapt to an energy-poor world. So the GEO is an extraordinary opportunity to both inspire and unite humanity while creating a new space energy industry. So this is all detailed on our website. Astrostrom, under the strategic partners rubric there, and then we're going to have coming soon the GEO website, which will be at geo.earth or geo.space. So I thank you very much for your attention, and if you have any questions, please ask me.
Thank you very much, Arthur. Any quick pressing question, because we're quite tight on time? Okay. Oh, please, yeah, go ahead.
Yes.
Could you comment a little bit on station keeping of the space-based solar? Would it just stay in its correct orbit, or would you need some?
Well, definitely there'll be station keeping involved, because you have all the forces in the orbital sphere. So even we would build the first one at the Earth-Moon Lagrange point. It's a semi-stable area, but it would need station keeping, and we'd probably use something like ion rockets and stuff to keep it going, or AI.
It's interesting. Could be a demand for, oxygen production on the moon, perhaps, as well.
Definitely. Once we get the manufacturing thing, we would beneficiate all kinds of materials, and you'd have all the byproducts coming out of it. Oxygen, for example. Rocket propellant would be also a byproduct of this whole operation. Yeah.
Thanks.
Sure.
Thank you so much.
Thank
we
you.
thank Arthur. Thank you so much for being here. Please put your hands together once again for him. We move on to our next presenter. He is Filip Wylęgała from AGH University of Krakow, and he will be talking to us about Lunaris payload, a novel approach to lunar exploration. Over to you.
Thank you very much. Hello, everyone. My name is Filip Wylęgała. I'm a PhD student at AGH University of Krakow. And today I will be presenting you Lunaris payload. So Lunaris payload is basically an outcome of experiment on the moon competition. That was a challenge organized by Orbital Space. Orbital Space is a company based in Dubai that tries to make the space accessible to all by organizing science competitions like sending the experiment to International Space Station, sending CubeSat, and now the prize in the challenge was to send a lunar payload. Our team won the challenge and we secured a place on a lunar lander with planned moon landing by 2025. It will be the first private payload from Arab world and also first Polish-built lunar payload. So for sure we are all familiar with the dusty problems. I will just quickly recall the problems that we want to deal with, especially with this payload. So during the Apollo era, multiple mechanisms were compromised due to the fine dust particles. The dust contaminated, the adhesion of dust contaminated spacesuits, some cables that were laid on the moon. When astronauts wanted to brush off the dust, the fine and sharp regolith particles scratched some surfaces. Also, you have to remember about thermal control issues, so the settlement of the dust on some thermal control areas, or, for example, the solar panels may compromise and may possess threat to emission. So that was a problem. Now I will quickly tell about our motivations. So last year we were here with our project, our Connect, that was also pre-incubated in ESRIC startup support program. So this is the idea of having a genderless dust passive power connector that could be operated in the environment of the dust, in the presence of the dust. When we were developing the connector, we found a problem that we didn't know what materials to choose, what coatings to choose to have this passivity, dust passivity feature. That's why we proposed our idea for a payload. So our main goal is simply to design, build, test, and operate a lunar payload in order to test the interaction between the lunar regolith and different materials potentially that could be used in future lunar missions. Additionally, we want to also measure the radiation profile of the mission using a small dosimeter. So the payload is very small and compact. It will weigh only 200 grams. The structure will be 3D printed out of some polyamide reinforced with carbon fibers. We will use 0.2 watts in average and 0.5 watts in the peak power. We will be also some data transfer limited. We will use space-grade components, of course, and half of the electronics we buy, half of the electronics we design and manufacture in-house. We will be using a small space-grade camera that was initially designed for CubeSats. We will visualize a plate using it. We will have also a LED ring to enhance the visibility of the regolith that will stick to the plate. So the process will be very simple. We will be having a LED ring with different light sources in order to to have different light scenes and to take multiple pictures, and then we will be able to post-process it. So this is how it will look like. We will have a checkboard of different materials. Probably it will be 8 materials, and it will be each sample will be doubled. So this is how the payload looks like. Yeah, it's very small. So now I will play a short video. So we will be using a commercial available lander. We will deploy the hatch and the anchor plate will fall from the bus. It will gently touch the moon, and then using a small stepper motor, we will raise the anchor back to the bus, and using onboard camera, we will visualize the regolith particles that stick to the plate, and we will enhance this with the lettering. Then, after compression of the images, we will send them back to Earth for further analysis and post-processing. So, as I said, we will be using CubeSat camera, MVP Aerospace, KissCam. It has some space heritage in CubeSats. We will be using very small, the smallest, actually, a space-grade radiation dosimeter to measure the radiation profile of such moon mission. The material that we will be using is a CRP Windform XT 2.0. This is material that was previously used in some CubeSat projects. It's a company from Modena, Italy, that will manufacture the bus and all the structure. So why we have chosen the material and the process of 3D printing? It gives us the freedom of prototyping, of doing a lot of iteration. We work in a workshop style work. So it gives us the opportunity to iterate very fast and to change to change simply the structure. So besides some qualification testing, we are also doing some tests. For example, here you can see radiation testing of some components. Of course, all the tests will be published in order to use it. We were testing some optical components. We can see, for example, the magenta line and a red line. This is the shift in the characteristic of the of some optical component that we will use as an end stop in our payload. So here are some main challenges that are in front of us because we are quite in the middle of the project. So we are also looking for some partners in order to succeed with these challenges, especially with the IT and electronics review, with EMC testing, TVAC testing. These are the main challenges that we have to deal with. And this is all. I would be happy to answer some questions if you do have.
Thank you so much, Filip, and I'm extremely sorry for not pronouncing your last name correctly.
Okay.
Really sorry. Is there any quick question? We have some time. Yes, please.
Okay, so just one very quick. It's Jakub again from Polish Academy of Sciences. So my question is whether you repeat this process several times or many times on the moon, or just one, and that's it.
So, like the baseline is to do it once. However, we have some. We in our ConOps operation we have also some let's say post-ConOps operation that includes multiple touching of the moon. We are very constrained and limited in case of the power and the time that we can operate.
Okay, thank you. And maybe just the last one. Where will be the landing, on highlands or lowlands?
It is not yet determined.
Okay.
So it will be in some time.
Okay, thank you very much.
Thank you. Thank you so much, Filip. We'll move on to our next presentation, which is an online one. We'll be hearing from Mateusz Józefowicz. He's from European Space Foundation, and he'll be talking to us about mirrors, mining data services in commercial data distribution platform. Do we have him ready? Yes.
Yes,
Over
I guess
to you.
so.
Over to you,
If we can-
Mateusz.
Thank you very much. Thank you for having me remotely. So this is actually the third time we are presenting Mirrors at Space Resources Week, and second time the Mirrors is presented during this conference because Jakub, who is present with you, has had the technological aspects presentation on Monday, and I will focus on our business development. We are progressing surely and not that slowly, but actually we have a consequent plan that is synced to lunar opportunities. Mirrors is an initiative from a consortium of Polish Academy of Sciences, two units and some SMEs. But right now we are, I just try to change this slide if I can. Okay, oh, there we go. Right now, we have completed the consortium project, which was run based on ESA business applications, and we have developed a drone version of our spectrometer. So Mirrors is all about far infrared spectrometry for mapping of sulfide and oxide ores. We are focusing on metal ores and on prospection. And we have proposed commercial applications of this technology on Earth, which are challenging because of the water content, which obstructs the view for far IR spectrum. But with the drones, it's much easier to operate this technology, especially in arid and polar areas. So we have completed the drone version, and we are deploying the first services based on the drone version for the terrestrial clients, but also for space clients who are interested in studying the analogs. Because we are focusing on materials and minerals that are also available on the moon and which will be the subject of the moon mining in the future. So after 2.5 years of the project, we have also applied for the ESA BIC. So now, besides the big consortium, we also have a spin-off from this technology, and we've just signed last week the ESA BIC Poland agreement, and we will be focusing in this project on the distribution of our data. So the first stage was actually to acquiring the data, and the second stage is the distribution. And part of this distribution process is going to be commercial. I'd say a big part. This platform will allow us to do the data fusion. So there are a lot of available data sources, both commercial and open source, for the terrestrial mining and also for the emerging lunar mining. So the red parts are our generic data that we gather, and we will gather during the upcoming lunar missions. I'm talking especially about the Polish initiative, POLSA, Polish Space Agency lunar mission, and possibly the OSIP ESA small lunar missions and lunar mineralogy mapper. Those initiatives focus on providing new opportunities for instruments to be carried on lunar orbit to map the data. But we are, of course, also expert in fusing all the available data sources. Our missions will focus on the moon, mainly on the Maria, as Jakub has mentioned, and there is some rationale behind it. There is a big race to the lunar poles, to lunar water, but we are focusing on the metals and possibly also on the oxygen that it is in the oxides. But the lunar Maria have also this big advantage of being well calibrated with the Apollo samples. So this is not a purely scientific surveying. It's rather more practical. We are getting more step towards commercial feasibility assessment with those well calibrated data. So our platform will basically be mineral-centric. So we will include the spectral library that we are building for the sulfide and oxide minerals. Especially, we are focusing on ilmenite, troilite, also pyrite, as has been mentioned by Arthur, by Tavi, also for the future production of solar panels on the moon. But we also are able to detect minerals that carry platinum group metals, some other metals such as nickel and cobalt. And while they are not as abundant on the moon as the ilmenite itself, we are able to detect them both on the moon and on Earth. So we are actually, our platform will be transparent to the origin of the data. So we can analyze both the terrestrial data and the lunar data. For now, we have deployed first services, which are the consulting services with our geology team. We are building the data platform, but we are also already consulting on the strategies for the lunar prospecting and the lunar mining. So if you are interested in those services, we are already there. We will also have the parallel expertise in terrestrial mining, which is a standard prospecting company profile. The additional opportunities we based on ESA support, and we base on those proposals that are expected to be announced in 2 or 3 months regarding the lunar missions. But since this is a commercial project, we can also discuss investment into the platform itself, because this platform can be developed and can include also spectra for the terrestrial mining. But also we are examining the possibility and interest on the market into offering investment into data. We are not talking about the tokenization for the tokenization's sake. So we are not rather exploring the NFTs, etc. But since you cannot own the moon, you can still own the data about the moon. So some kind of a tokenization approach to the lunar maps that we will be generating will be available. And with that, I would like to conclude my short pitch. And if you would like to talk to us, we are available. So Marta and Jakub are there. So you have still some hours of the conference. So maybe if you're interested, you can talk. Or if not, we are also available remotely. And that's all for me. From me, I know that there are no time for questions, but hopefully see you next year.
Thank you so much, Mateusz. Yes, for online talks, we are restricted and we don't have time for questions, but I recommend that you please contact him and ask your questions, or you can wait till the next year to see him. Thank you. Thank you so much, Mateusz. We move on. Please give one more round of applause for him. Thank you. We move on, and our next presenter is Olivier Usher. He's from Challenge Works, and he will be talking to us about the Aqua Lunar Challenge, an international innovation prize for lunar water purification. Welcome you.
Thank you very much. If I've learned anything from the past couple of days of hearing all the talks today at Space Resources Week, it's that there's a real shared vision of what the future lunar economy looks like, of future robotic missions to the moon, of crewed habitats, of resource extraction, of journeys perhaps beyond the moon to the asteroids and to Mars. And there's a kind of critical enabler that really links many, many of these different visions of the future of the moon, and that's access to clean water. And the real critical enabler for clean water, and indeed many of these other things which are needed for the future lunar economy, really come down to innovation. And innovation in space has come in many, many different forms over the years, many of them really about making impossible things possible. We've all heard the stories about how things like Velcro and Teflon and digital cameras were developed specifically for the space sector before percolating into the rest of the economy. But let's not forget either that innovation is also about optimization, about processes, about manufacturing, about services. You know, the radical reductions in costs that we've seen, for example, coming from Elon Musk's SpaceX, we're not about doing new things, but we're about doing things better and more efficiently. So innovation is a really critical element of how we move forward towards the future of space. But where does this kind of innovation come from? Well, it comes from a lot of the people we see in this conference today. It comes from people in the primes. It comes from the startup ecosystem around Europe. It comes from the universities. It comes from the research labs. But innovation doesn't always come from these obvious places. It doesn't always come from the usual suspects. Innovation can very often also come from unexpected sources and from innovators who often get overlooked. And that's really the principle behind open innovation. Open innovation programs are things which are used often by governments. They're used by foundations, by philanthropic organizations. They're used by the private sector too, and they're used in situations where organizations want to look beyond the usual suspects or want to look beyond their own in-house research and development functions to find solutions to problems that they find important and solutions that they need. And one particular modality of open innovation is to use challenge prizes, which are what I'm a specialist in at ChallengeWorks. And challenge prizes are financial rewards that are offered to people who can either first come up with a solution to a problem that you define, or who, at a kind of deadline that you set at some point in the future, are able to best demonstrate that they've fulfilled that technological or social innovation goal. And challenge prizes have been used pretty extensively across the world in the space sector. You may be familiar with Ansari X Prize about 2 decades ago. This is really what kick-started space tourism. The whole technological platform of Virgin Galactic goes back to the scaled composite team that won that back in the early 2000s. More recently, in Canada, the Canadian Space Agency recently announced the winners of the Deep Space Healthcare Challenge on telemedicine. NASA also is, of course, an extremely wide user of these through its Centennial Challenges program, in reinventing, not least, the astronaut glove. And they're not just a thing in space. So my organization, ChallengeWorks, also runs the Longitude Prize, which is a thing designed to kind of solve the problem of antibiotic resistance. Homegrown Innovation Challenge in Canada focuses on revolutionizing agriculture. DARPA in the US has used challenge prizes to drive forward the future of autonomous vehicles. And indeed, many of the technologies you see today on driver aids really draw their origins back to the teams that competed in DARPA's driverless car challenges back in the 2000s. And challenge prizes really are about kind of trying to do 3 closely related things. One of them is around supporting a pipeline of innovators coming into the field by supporting and giving opportunities to unusual suspects who might struggle to qualify for a government R&D grant or might struggle to convince VC funders. They are, of course, about creating the new technologies themselves. They're about rewarding the creation of advanced and innovative new ways of solving problems. There's also a broader contextual piece around the ecosystem, the supporting infrastructure that exists around innovation itself, which might be in the form of public awareness or policy change or in shaping markets. And I guess this brings me back to where we are with lunar resources now, because I think that lunar resources really need all 3 of those things as well. We need the new technologies. We need the breakthroughs in how you filter and purify water. We need the pipeline of talent. We need the new ideas, the new people, giving a chance to people who perhaps don't attend Space Resources Week, but have ideas that could help solve those problems. And we also need to really put this on the agenda of policymakers and raise awareness of this with the public and with investors to facilitate the future of these technologies. And so that's where the Aqualunar Challenge comes in. So it's a UK-Canada Challenge Prize. I'm heading up the UK portion of this on behalf of the UK Space Agency, and there's a parallel track taking place in Canada. And this is a challenge prize where we've set a technical target of creating a water purification technology capable of purifying water in situ on the moon. So assuming that somebody else has extracted the kind of raw water from the regolith, but the technology which can take that and turn it into 1 litre per hour at least of pure water, suitable for use to drink, to grow crops, or to turn into fuel rockets. It's structured around a mission scenario. So, to try and make this a bit more tangible, we've asked the innovator teams competing in this challenge to picture themselves on the edge of Shackleton Crater, dropped there by an uncrewed lander, and provided with this source of kind of raw, dirty ice or dirty water from a regolith mining operation taking place within the permanently shadowed region. And using minimal power, compact equipment, lightweight, robust, and autonomous tech, we're asking them to take that dirty water and to turn it into something clean. And there's a whole kind of series of criteria that sit behind this, which you can see on the Challenge Prize website at aqualunarchallenge.org. And so this is kind of what the structure of the challenge looks like. It's a UK prize and a Canada prize running in parallel. Towards the tail end into next year, the final stage looks slightly different. But for both the UK and the Canada components of this competition, we are in the open period right now. So if you have an idea on how to do this, you can apply. The deadline is on the 8th of April, so there's still a little bit of time to fill in your application. It's a pretty kind of low bureaucracy and simple form to fill in. What we're looking for right now is just an idea. It's a form filled in with your technological concept and some information on your team and how you think you can solve this problem. But then, starting in a couple of weeks' time, we will have a process filtering this down through expert review and an expert judging panel who will pick 18 teams, that's 10 in the UK and 8 in Canada, to receive a whole package of financial and non-financial support to help them develop their technology over the months and years to come, with winners picked at the end and offered financial rewards for those who did best according to the criteria. Sitting behind this, as I said, are the UK and the Canadian space agencies. My organisation is working on the UK Space Agency side of things. And to briefly touch on the policy context here, the UK Space Agency is governed by a thing called the National Space Strategy, which places huge importance on innovation as a critical enabler for the UK space economy, but also on ISRU as a future opportunity. But even more than that, this is funded by them because it's a programme of international collaboration. And it comes from a pot of UK Space Agency money called the International Bilateral Fund, and we're really glad to have their support. I can't speak for our Canadian colleagues, but I do know that for them, a really critical element of this prize is demonstrating that technology developed for space also has impact for Canadians on the ground. And I think this technology is a really good example of that, because lightweight, compact, low-energy water purification technology for use on the moon is also something that's going to be enormously valuable on Earth, wherever that kind of technology is needed. As for me, why am I excited in this? Because unlike most of the people in this conference, I'm neither a space agency employee, I'm not an entrepreneur working in the space sector, nor am I an academic working in this field. I organise technology prizes, and ultimately my job is to find these kind of exciting problems that people can come in and work on, and to try and motivate them to take part in organised contests like this. And for me, I think it's really hard to think of an opportunity more exciting than to facilitate the future of humanity on the moon, going to the asteroids, going to Mars, and perhaps beyond, and to enable the future of some of these amazing ideas that we've heard over the course of this conference this week. So if you want to take part, you can still apply. 8th of April is the deadline at aqualunarchallenge.org. That will let you click through to either the Canadian or the UK entry form. It's really simple to fill in. An Apply Now button, and that website has all of the information that you need around the competition rules, around the criteria, around the mission scenario, and hopefully everything that you need. But if there's anything that you need that you can't find, there's ways to book appointments with our team to kind of have a chat and to discuss your application and learn a bit more about what's expected of you. So I've been Ollie Usher. I'm the head of research at ChallengeWorks. We organise technology prizes. I sincerely hope you consider entering this prize. And equally, if you are interested in organising technology prizes like this in other sectors, we're always happy to hear any thoughts that people have. Thank you very much.
Thank you so much, Olivier. Do we have any questions for him in the room?
I have one very easy for you and fast, probably. Why you choose this topic?
So the topic was actually chosen by the Canadian Space Agency initially, and then we joined the kind of UK arm onto this. I think in situ resource utilisation is something I can't speak for our Canadian colleagues, but I think it does feature in their space strategies, and it certainly does in the UK national space strategy. So it was a kind of topic that was current and a topic that was important. As for picking water, I think it's a topic that speaks for itself as one that has really obvious importance as an enabler for what's happening up there in space, but also one that can speak to challenges down here on Earth. We're working with a number of organisations to support the innovator teams coming through this challenge, not just offering them financial support, but helping them along the way to find business opportunities and investment opportunities for their technology. And we're quite aware that with a lot of the space technology, you're looking at somewhat speculative, quite long-term use cases and a somewhat kind of difficult path to financial viability. So we were looking for something which had clear benefit on here on Earth as well. And you know, we've already had interest from mining and natural resources firms and from engineering consultancies here on Earth to work with the innovator teams that take part because they're interested in them for their much nearer term Earth opportunities. So I think it was a kind of happy combination of inspiring goal, kind of clear space use case, but also business opportunities here on Earth.
Thank you.
Okay. Yes. Thank you.
Thank you. Thank you so much. Thank you so much, Olivier. Please, a big round of applause for him. Our next presenter is Sam Ximenes from Astroport Space Technologies. I would like to take the opportunity to highlight here that Astroport is from ESRIC-supported Startup Program 1, and they have their office in Luxembourg as well. His talk today is on fixed-base operator services at a lunar astroport. Sam, please.
Well, thank you for inviting me here to talk about what we do at Astroport. As mentioned, we are a graduate of the first space support program from ESRIC, and in that program we were able to make a lot of friends, collaborations, and it's really a program I would recommend to anybody who's trying to be an entrepreneur. Thank you, Larry. Oliver. Okay, so let's talk about what I want to do today here. Fixed-base operator services. This is essentially the business case of how we run a landing port, an astroport. What is the business case for actually doing this? Before I go into the business case, though, I'm going to talk to you about why we actually and how we get to that part of it. So Astroport is looking at not only construction technologies and materials that go into the creation of the Astroport, but also the operation of it. That's our end game, is to be the operators of to provide that service. Now, how we do that as an end-to-end system architecture, we look at space materials. What's the construction material that we use to make the construction of the landing pad? The robotics and the autonomous applications of those robotics, those technologies, and then eventually, finally, the operations of the Astroport landing pad. So, to do that, we have to go down to the core material. We all know about regolith and its use as a building material. We have to understand the granular level, the dust applications of it, how that impacts the construction processes, the ability to make the pavement that we want to use for the landing pad, and also how we can use it for extraction of additional resources as well. The oxygen, the gases, the metals, and fuel that could be used out of that resource. So at Astroport, we've been focusing mostly on the actual material itself, the construction of the bricks. So there are many ways to do the cementitious hardening of the solidification of the regolith. You could sinter it, you could laser it, you could make it a cementitious material. Our approach is to turn them into bricks. Essentially, we just melt it. We don't even add anything to it. There's no binders in it. It's just a pure melting of the material. And we've been experimenting with this for a good 2 years now. We finally got to, these are full-size bricks that we've been able to, and this is the form factor we would use for the pavement. The way this would work is these bricks would not need a grout or a mortar to adhere to each other. We have a proprietary method of placing the bricks down with a nozzle what we call an induction nozzle machine, or lunatron, and those bricks adhere to each other as they're placed one at a time. You can see here some of the picture there with the hand. That's our first instance of being able to fuse the bricks together. This fusion process that's where we're at now in our current research and development. And then, in addition to that, is making the bricks in vacuum. The bricks you see in the middle there was the larger ones. Those were cast bricks in a furnace in ambient air, and you can tell the density of those. They're pretty strong. They're stronger than high strength concrete. But the vacuum bricks is another story. Making the brick in vacuum is still a challenge to us, to anybody. I don't know if we've got anybody that's really solved it so far, but we're getting there. We've just invested in a large induction machine, a heater that's going to give us the power and quality of the heat we need to have to make these bricks dense. So that's the next step for us, is to get the bricks out of the vacuum, produced in the same quantity and the densities that we can do it in ambient. So the other part of this now is the construction process. We just completed a 13-month study with NASA. We're funded by NASA, by the way. We've received over $1.3 million in funds from NASA to develop the construction technologies and the brick making portion of it. We're an international consortium. We're a global team. As was mentioned earlier, not one company can do this. We have an operation in Australia, our operation here in Luxembourg, and then we're based, of course, in the United States. We have 3 universities that are part of this. The University of in Poland, and there's another one in Australia, and then one in San Antonio that we're working with. Companies here also we're collaborating with is another ESRIC graduate company called 4Point, collaborates with us for the beneficiation and the distribution of the regolith as well. So we have a large consortium of a team, and we've gone through this report, the ConOps that we developed for NASA, that showed what is the actual end-to-end system deployment of the way to put the assets on the ground, the delivery of them from the Starship, how you set up, how you stage, how you lay out the site of the different activity zones. How do you set up the power system, the communication system, the shelter system, and the spares and all these other aspects that go into it. The robotics that go into it, the different platforms we're using. We have a very specific ConOps that is specific to the brick making process, and that's important. The brick making process, it really drives the way we develop the ConOps. And the ConOps it drives all the assets that are required to support the excavation, the construction, the ability to do the beneficiation, to do this grain separation and distribution of the processed regolith to the brick makers, and how they get to that, and how they do that end-to-end system where you actually have the pad at the end of it. We just received some additional phase 2 funding from NASA. We're going to go into additional more detail of the ConOps and develop some of these technologies that were derived out of the phase 1 study. So we're going to go into the distribution system of the regolith, and there are some patentable things that came out of that study for us. So, okay, let's talk about why does this relate to the FBO. So an FBO, a fixed base operator, is a very common business model for general aviation airports. There's one company, one that's contracted to be the operator that there's the maintenance of the coming and going aircraft, the refueling, the maintenance and depot for services. That's the fixed base operator. We're going to apply the same concept to the operation of the landing port. We believe the landing port is, of course, the gateway to any camp being developed for mining operations or just basic research. And what's developed around that camp is all these different operations for extraction of oxygen, metal extraction, and EISU production facilities. In the construction of the landing port, we're moving tons and tons of regolith, almost 25,000 tons to 50,000 metric tons, depending on where you're located at. And in that excavation process, that feedstock becomes, that regolith becomes the feedstock for our brick-making machine. And the feedstock then is going to be left over. It's going to be spoils from that. We have a process in our way to do the distribution of the regolith and the sorting of the grains as well, but we'll have stockpiles left over. So those stockpiles of regolith will become processed regolith, down to from anywhere from 20 to 50 microns, even 70 microns, depending on the usage. Our brick making only needs 70 micron regolith, maybe the oxygen production probably 20 to 50 microns, depends on the ISU process. And we'll already have that stockpiled from the construction process. So we actually have a materials yard that has been created at that location. And that materials yard then will be able to be a supplier to these other operators that are doing oxygen extraction or metals extraction. And we would supply them with the processed regolith. So they don't need to be in the business of digging up regolith or being in the mining business. They're just there, they're going to do what their product wants, their end product is trying to obtain. And we would deliver that to them as a commodity. So regolith becomes a commodity, a sellable commodity to these operators as well. And that model, that cartoon just shows how that would work in terms of we can distribute all these. Part of that, though, is the containment system we have. We have a technology where we contain the regolith in these canisters, and then now we have to deal about how do we feed the other operators. There should be a standardized aperture, basically, for the delivery of that regolith into that mining or that production plant. And we have a technology that we're developing for that. This is what we call a regolith canister. The other part that comes when we get down to actually more infrastructure built around the landing port will become a maintenance and depot operations. We have technologies we're developing that's going to be able to recycle the lunar landers that are left behind. There are some concepts of landers that have descent stages that are left behind. You got to get them off the pad, and they can be refurbished, recycled. We're doing, and this could be a number of different types of technologies for that. One in particular we're working on is one called friction stir deposition, where we just dismantle the aluminum out of the regolith. We actually combine it with the regolith to make that scarce material of aluminum go further for creating stock material, bars of aluminum that can then be recreated into other usage for wheels from rovers or spare parts, that kind of thing. And then eventually you become what's called a MRO facility. It's a very prevalent concept here for aircraft maintenance, where we're doing maintenance, repair, and overhaul. And then of course we have the landing fees and we have the offloading fees, and these are all the business cases that we can use to generate the revenue out of the landing port operations. So in the end here, I'm just going to end with this one. This is just our concept of where we want to get to. By the end of the decade, end of the century, hopefully we're at a point where we have a thriving lunar economy. We've got operations of coming and going spacecraft. We've got the facilities there for habitation, but you can't get there until you have the landing pad built. That's the very first infrastructure you need to build before you begin any kind of thinking of a habitation, a long-term stays or settlement on the lunar surface. And the picture there with the rocket, the Starship, that's our initial operational configuration. It's just the basic core beginning of that stage. And with that, I'll end. Thank you very much.
Thank you so much, Sam.
Any questions?
I think we are a bit over time, but we can take a quick question. No? Okay, no.
No?
One
Okay.
easy one again, because I know that in the room we have young guys that would like to follow your path somehow, opening new companies in Luxembourg and so on. So I would like to know how it came that you open in Luxembourg, because you are from Texas.
Yes. So when we competed for the first cohort, we were the only U.S. company that was selected out of, I think, 17 contestants. So being that company, we went through the program and we visited here as well and had collaborations with Luxembourg companies that were interested in this. We continue those collaborations, and we saw that there's a business here. Let me be more frank about it. We need to have all the different agencies and governments that are involved in resource utilization. That's why we're in Australia, because we can tap into the money of Australian money. We can tap in now into the European money, and building those companies up in those countries. They're wholly owned subsidiaries that are the profit centers in and of themselves, tapping into those resources from those different agencies that are producing the catalyst programs. Same thing in the United States. So this is the process of the globalization of our company to bring in all the resources that we need to have from different, wherever those pockets of funding are existing as well. And Luxembourg is a very ripe area for this, and it's very supportive.
Thank you.
Okay.
So it's the ecosystem.
The ecosystem, exactly.
And the support that you are having from the states.
Exactly.
Thank you.
Thank you, Mitch.
We have one more question, Sam. Sam, we have one more question for you coming up.
Oh, okay.
Sam.
Sam, I just wanted to ask you if you would explain to the audience what your concept of workforce development is that Astroport is sponsoring for youth.
Yeah, thank you for that. So Astroport has a nonprofit organization called WEX Foundation. And what it does is it takes the challenges that Astroport has in terms of technology development and provides them to the student programs that the WEX Foundation develops. And these are middle school to high school programs. And we give these students the same opportunities to solve problems that would be solved by the commercial companies. And we do that and that develops our workforce development stream. We want to be, wherever Astroport will go, so comes WEX Foundation to be part of the community. We reach out into the community to develop the workforce of that community to be part of the ecosystem that Astroport is trying to develop in the development of these technologies as well. And we're trying to, we'll be doing that here in Luxembourg as well with the WEX Foundation.
What's the name,
WEX, WEX Foundation.
What does it stand for?
My father's initials. It's in his honor, Waldo E. Ximenes. Okay.
Thank you.
Right.
Thank you so much, Sam.
Sure.
Please give a big round of applause for him. Moving on, our next presenter is Olivier Zephir from Technoport. I would take the pleasure to mention here that we, ESRIC, work very closely with Technoport in the field of commercialization, specifically in the incubator program. And he's talking to us today on Space Tech Business Incubation. Welcome, Olivier.
Thank you. Thank you for mentioning currently the collaboration my brand, the Technoport Technology Business Incubator, is having with ESRIC. First, quick thing, let me know to which audience I'm speaking to. So Technoport, my brand, just to tell you who we are a private entity with that mission statement of bringing technology business concept to success. How are we doing that? Yes, we're a private company. We have two public shareholders, the Ministry of Economy of Luxembourg and a public bank which supports early stage ventures, which is currently the SNCI. Before continuing, I want to know what's the audience right now. Who's from a research center or related academia research institute? Please raise your hands. Oh, interesting to know who are the other ones then. Other ones representing a private entity, private company? SMEs, startups? Okay, then you understand for the private companies what it means to bring a positive accounts yearly. Now we are speaking to an audience who understand. I have a PhD in industrial engineering as background. I did testing in aeronautic and aerospace industry. Just to understand that I come from that technical background and now speaking that business language and more specifically about deep tech portfolio. This is what we support in our technology business incubator, but let me get down a bit to to what's our footprint. Most of the time we see incubation by the footprint occupation that you have. Just to say, as we are following public policies, that's why we have the Luxembourgish Ministry of Economy as our shareholder. Our mission statement is to support enterprise, meaning we have 4,000 meters square of offices for software-oriented enterprise. We have 12,000 meters square of industrial warehouse, where you have, for example, Lunar Outpost, which presented this morning, which is sitting with us. Yes, I'm a kind really of a show me, don't only tell me policy. I will give you a bit of some brands, you know, that we are working with ESRIC for that incubation board. And we have intention in health and automotive, but let me get back to the purpose of what we want to share with you. What Technoport wants to share with you, whether you are maybe a business to research or to research to business entity. For example, we have collaborated with AGH, which is just right here with a connector that currently the team has brought within the ESRIC program. Our point is to understand how can we be the best bridge to your concept. We know on our side what other laboratories we have in Luxembourg. We can bridge you currently to further mature your technology in Luxembourg. And inversely, if I'm hosting a company here in Luxembourg, I want to know what I can have currently in Krakow, in AGH, to mature better the TRL of that company within my partners network. Market and technology knowledge, yes. For example, thank you, Dorian, for your presentation. Business intelligence is key to us. This is what we want to share with enterprise, which are right here. We will have some fun speaking about company valuation and investment. Generally, when you see early stage companies, most of us will give numbers such as, hey, we have leveraged 20 million at our Series A. I say, oh, good, 20 million Series A. Who's going to buy you later? If we do a 3 to 5 times valuation in the next round, what I mean, yes, we do in the investment early stage business valuation. This is very good, don't get me wrong. But on the cohort of companies going into that area, let's take traditional industries. How many tier 1, tier 2, tier 3 providers you are seeing in that industry? This is what I want to see with my partners, and thanks to Lari Cujko, who is sitting here, who's running also that program. We are seeking to look for the different players that will contribute to the space resources. If we can say if there's a space resources network, we want to see who are the next players. And again, to quote Dorian, we want to know who are these players not coming from the space tech per se, but who are potentially financing parties or parties who are going to buy these space tech companies. This is why then we name Technoport as an open innovation ecosystem builder, because this is part of our mission to bridge those different players. And then you will say, hey, okay, he's speaking about incubator, but what other companies you are hosting? We are vertical agnostic, but again, I told you about how we are built. We are built with a partition of capital from the Minister of Economy. Of course, we follow national policies. It's no secret to anybody being seated here, and thanks again, ESRIC, for organizing this event. ESRIC is bringing the world to us. So it's our mission to understand what's the technological trend. That is why in the 24 plus-ish companies we are hosting currently, Technoport can host 25 to 15 companies as a mean. But when you're saying, oh, okay, it's only 25, no, it's the number of people who are presented by the cohort of companies here. Here, these companies you're seeing listed over here represent at least 200 people. So we are across different verticals, and this is where I will get in the topic of the talk of today, commercialization and also public-private partnership. This is what we are learning quickly with incubated players here. And when we are speaking about incubated companies, we are speaking about early stage ventures. Yes, we work with early stage companies, 3 people building a team of 20 plus. Yes, we are working with SMEs, and I'm going to give concrete example because I do believe in space resources would be good to have SMEs doing early stage ventures. No, early stage ventures is not allocated only to startups. You can have spin outs or even spin in from what I call competitive early stage ventures within SMEs, and we do collaborate with corporates too. But let me deep dive just to show quickly. In the space-related, space operations, I will call them, you will see some names that most probably you saw within the conference. And thanks to ESRIC collaboration, we were able to grow that pool within the startup support program. And I invite you, again, show me, don't only tell me, you can visit, if not done yet, you still have time. You have the startups being incubated through the ESRIC Startup Support Program, who are presenting at the booth, where you can meet Litigo, 4Point, Space, Solstice Mining, Space Backend, the latest company being accepted. These are the companies that you can see up front. Of course, you won't read the details, but when you will look at our website, you can go through these companies, which we allocate them to the space tech area. But space tech area is not enough to describe these companies, because these companies are doing dual applications for some of them. Here I'm listing the companies who are related to the materials and resources sector within my portfolio currently. And some of them are the same companies that you're reading into space, that are currently related rather also to the material sector or to the resources sector. What does it mean? It means that to be currently sustainable in that area of space application and developing a space application, some bunch of them are also having a return within the terrestrial market. So what we want to learn from this experience of the pool of hosted company, how you design, how you test, and how currently you operate. This is what they do with a technology business incubator. Within ESRIC and other support programs, we are able to collaborate directly with corporates. Corporates are necessary so that you can benchmark how your company can collaborate. Again, we need to show what are going to be the tiers relation in that industry. This is a must-do. So currently we are hosting a company which is Carraro, has opened an office in Luxembourg. This is a currently heavy engine manufacturer across different industries, mainly based currently today in heavy operations such as agriculture and other equipment provider. I won't give more details about Thales Alenia, who is sitting also with us at the Technoport. And we have GLC Guala Closures, which is a company, is the worldwide leader in caps production, yes, bottle caps, and developing their IP within us. Currently, we are the soft landing ground for these players for developing their R&D lines in Luxembourg. What I wanted to name the present of corporates. Corporates are important to us to know how potentially can we do joint ventures. What happened, I express our incubation program where we host companies from 3 to 5 years, but we have also an acceleration program, meaning we are covering more or less the end-to-end early stage business development perspective, early stage, meaning company growing with us will grow a company, let's make it quick, from a 2 million revenue to a 20 million revenue. When you go up more than this 20 million revenue, this is where potentially you can have a match with our acceleration vehicle, which is Tomorrow Straight, meaning you have enough revenue to think of whether I'm growing organically or do I want to share currently my future business development perspective with a big account which has already providers and customers on both ends. So what we do sales deals. So why I'm exposing this? I'm exposing this, there's a set of brands in Tomorrow Streets, but you get into further details in that. Why I'm exposing this? I'm exposing this to say in industry being nurtured, such as space resources, and this is what I share on a day-to-day basis with Lari Cujko, my partner in SSP commercialization, is how to escalate things across industry players. How are we going to speak about the cohort of SMEs being involved into space resources? How are we going to speak about the leading research organization in space resources being able to support the development of that industry? Another element which is important to us, yes, we do run hackathons on our side too. I hope to be able to run challenges. Why not? Why we do this? We do this to show that we know how to do rapid prototyping in Luxembourg. An example I'm giving here, it's a space hack competition. Who's involved into the space hack competition? It's that SME who's currently sponsoring this event in the name of Gradle. You can visit them up there. They are producing lightweight materials. Here again, you are seeing the mix of who are the players who wants to contribute into space resources, a lightweight material producing company, an equipment producing company who participated with us into this hackathon. The hackathon is a 24 hours, nothing new, but what does win the hackathon winner? The hackathon winner wins to come and demo your prototype in Luxembourg. What they did, they prototype currently their lunar rover, which they tested at the SNT, another listed partner over here. They tested the lunar rover being 3D printed with basalt fiber. Why are we doing that? We are doing that to showcase that we know how to design and test quickly in Luxembourg. And this is the capability we are further now developing also with the ESRIC support program. Test your design, test stress your design. The moon is a harsh environment. Testing is key. Even testing the testing plan is necessary. Yes, I used to do that as a humble technician. You've designed your test plan. Who's validating your test plan? How can further stakeholders trust you to know, hey, your test plan is the best currently path you should follow to validate your prototype? This is what ESRIC SSP is built with. Of course, Lari Cujko can give you further much more details on how currently we are now out at our fourth cohort. Fourth cohort meaning we have 20 companies which ran through the phase 1. We have now 20 companies which ran through this phase 1 of currently this startup support program, meaning where companies are able to qualify and validate their proposal. We have some Ximenes who just have the speech right now, who's part of that cluster, we can say that. And some can advocate how B2B is ongoing, B2B talks is ongoing with these 20 companies who onboarded the phase 1. Of course, not all the companies can be selected to the phase 2. Under the phase 2, the company currently gets allocated 200 kilo euro to come and test their prototype in Luxembourg. This is what I wish to the future companies coming to our program. But again, it doesn't mean that if you're not onto phase 2 that we won't work with you. Remember what I mentioned. I do believe with the ESRIC Startup Support Program is a call to consolidate a cluster. A cluster of industrial, a cluster of SMEs, a cluster of operating private companies will be able to say, hey, I'm working into the space resource industry. I'm able to make that revenue to employee return ratio. This is what we want to speak with. And when we can give further details currently of how can you better build up your company and receive even more financing from Luxembourg. So we don't do that alone, of course. We have this mission statement to bridge you more quickly possible into our ecosystem, rather financing, corporate, institutional, and research and academic. And this is what I'm looking forward to exchange with you on a further basis. And Technoport itself, our mission statement is to bridge you to our international partners. Yes, we are little, tiny from Luxembourg, but we believe in Luxembourg we punch higher than our weight, to quote our US partners for that term. But what we are looking forward to is to share with our network of incubation partners. You have European Business Network, which represent on the top left. European Business Network is more than 1,200 other incubation centers into Europe. These are my partners when I can query to say, hey, I saw an original company, I saw an original research from Luxembourg into the Space Resources Conference. Do you think that anybody's interested by that value proposal? This is what we do. So again, design, test, and currently operate. This is the value that we can share also with IASP, International Association of Science Park. Again, a worldwide Science Park partner, same than EBN, but worldwide distributed. Our point is to validate your value proposal quickly and make the best match to the market. And I hope that I was concise, clear enough in my explanation, and I look forward to see your application or further collaboration with the ESRIC Startup Support Program. Open to question, and will be a pleasure sharing further. Thank you.
Thank you so much, Olivier, but I think we're running quite behind schedule. So I would request anyone who has questions to kindly catch him in the coffee break and discuss further. We will move on to our final presentation of this session, which is online, and it is presented by Mark Sonter from Off-Earth Resources. He's presenting to us today on Off-Earth Resources, Shattering Paradigms and Creating Space Mining 2.0. Over to you, Mark.
Well, hello, everybody. On behalf of my colleagues in Off-Earth Resources, I wish to thank the organisers for this chance to present at Space Resources Week. We've been presenting at these meetings since 2018, and we look forward to continuing. We cannot be present in person this year due to a series of clashing meetings that could not be moved. The title of our talk today is rather ambitious: Off-Earth Resources, Shattering Paradigms and Creating Space Mining 2. Note that we've changed our company name from last year when we presented as Demos Space Resources. Can we have slide 2, please? Can we have slide 2? Thank you very much. We're an Australian startup with about 100 years of experience in terrestrial mineral exploration, mining and processing, and general resource project development, and a history in space resources studies via our early work with deep space industries. Our major thesis is that the basic concepts of space resources development must be informed by and aligned with the hard-won learnings of terrestrial resources development. Underneath that is the idea that space resource development projects are, when you boil it down, just mines, albeit very remote, very high value, and in very unusual settings. And the way to maximise our chances of success involves applying the disciplines which drive terrestrial resource project scoping, planning, and development. Can I have slide 3, please? Our vision is to provide in a sustainable manner the raw resources and fuel to support humanity's expansion into the solar system. Just imagine when we start supplying multi-thousand-ton payloads of water or propellant to orbital propellant depots from deep space production sources, that will change the entire development path of the space economy. Slide 4, please. Conceptually, the terrestrial resource development model is simple. You explore, you prospect to identify individual targets, you define and develop the project concept, then you construct and implement and move to commercial operation. Each step needs capital with spend justification based on data gained at the previous step. Interestingly, our modelling indicates that the CapEx of a first-generation space resource project will be similar to the CapEx for medium-sized terrestrial resource projects. We're presently focused on defining and funding a prospector mission. We talked about that last year, and that is progressing, albeit slower than we would like. Next slide, please. Next slide. Thank you. Some key actions over the last year are described in the next few slides. Firstly, we've developed the hardware, software, and operating specifications for a resource evaluation module to be landed on our specific target. The key with this unit is we're looking to obtain data specifically for resource development, decision-making, and investment. This is more focused than just pure science, and it's similar to the sort of comment that, who was it earlier on talking about the same sort of thing? Mateusz Józefowicz talked about commercial feasibility assessment with focused instrumentation as well. Slide 6, please. The second thing was that during the year we ran our second International Asteroids and Small Bodies Resources Symposium in conjunction with the Andy Thomas Centre for Space Resources at the University of Adelaide, and we're colleagues with Sam Ximenes in that same institute. This symposium brought together a great mix of people with expertise in small bodies resources, including JAXA and NASA people, and presenters from Colorado School of Mines, University of Central Florida, Orbit Fab Offworld, as well as a number of Australian institutions. Slide 7, please. So here are a few photos. here we are talking about the deep space industry's experience. Next slide, please. Here are some of the university students presenting on their robotics project that was related to our work. Next slide, please. Mike Nolan reporting on OSIRIS-REx. Next slide, please. Some of the presenters. On the afternoon of the second day, there was an open session where Australian and international space companies talked about their services and plans. The clear takeaways from the symposium as a whole were: one, the first commercial space resources missions are not far away. Two, there's a range of relevant capability that already exists both in Australia and internationally. And three, projects like ours are capable of providing a focus and bringing together the various services and providers. Next slide, please. During the symposium, we also proposed the development of an international space resources industry alliance. There are various space industry associations around, but none that yet specifically link space mining companies, nor that set out to speak for them in international forums. Such an industry association could, for example, develop industry positions on various matters, including codes of practice and aspects of implementation of the Artemis Accords, and so on. If you're interested, please reach out to us. Basically, that's it, folks. And once again, thanks to the organisers of this conference. We look forward to being able to attend in person next year with some exciting news. And final slide, please. Thank you.
Thank you so much, Mark. As it's an online talk, if there are any questions, I request you to directly contact Mark. And once again, thanks to all the presenters and the audience alike. We break for coffee now and are requested to assemble back in the plenary room at around 4 o'clock to continue with the rest of the program. Thank you very much, all of you.